I want to describe about introduction of electronic device, term of arrangement and movement of atom and electron up to the energy that involved in the device. Learning on semiconductor characteristic including current movement and structure of the device. Main semiconductor device from diode type, P-type and N-type, and transistor type, bipolar FET, and also photoelectronic device such as photodiode and LED.
Did you know about photodiode? A photodiode is a PN junction diode that consumes light energy to produce electric current. They are also called a photodetector, a light detector, and photosensor. Photodiodes are designed to work in reverse bias condition. Typical photodiode material are silicon, germanium, and indium gallium arsenide.
A photodiode is subjected to proton in the form of light which affect the generation of electron-hole pairs. If the energy of falling proton is greater than energy gap of the semiconductor material, electron-hole pairs are created near the depletion region of the diode. The electron-hole pairs created are separated from each other before recombining due to the electric fields of the junction. The direction of electric fields in the diode forces the electron to the move toward the N side, and consequently the hole move toward the P side. As a result of the increase in the number of electrons on the N side and hole on the P side, is a risk in the electromotive force is observed. Now, when the external load is connected to the system, a current flow is observed through it. The more the electromotive force created, the greater the current flow. The magnitude of the electromotive force created depends directly upon the intensity of the incident light. This effect of the proportional change in the photocurrent with the change in the light intensity can be easily observed by applying a reserve bias. Since photodiodes generate current flow directly depending upon the light intensity received, they can be used as photodetector to detect optical signals. Both in lens and optical filter may be used to enhance the power and productivity of photodiode.
Application for photodiode. First, photodiodes are used as simple day-to-day application. The reason for their prominence is in the linear response of photodiode to light illumination. Second, photodiodes are used in safety electronics such as fire and smoke detector. 3. Photodiodes are faster and more complex than normal PN junction diode and hence are frequently used for lighting regulation and optical communication. 4. Photodiodes are used for the exact measurement of intensity of light in science and industry. Photodiodes are used in the logic circuit. The last one is photodiodes are used in numerous medical applications.
Light emitting diode LED is a widely used standard source of light in electrical equipment. It has a wide range of applications ranging from your mobile phone to large everything earbuds. They mostly find application in devices that show the time and display different types of data. What is LED? A light emitting diode LED is a semiconductor device that emits light when an electric current flows through. When current passes through an LED, the electrons recombine with holes emitting light in the process. LEDs allow the current to flow in the forward direction and blocks the current in the reverse direction. Light emitting diodes are heavily doped PN junction. Based on the semiconductor material used and the amount of doping, an LED will emit color light a particular spectral wavelength when forward biased. As shown in the figure, an LED is encapsulated with a transparent cover so the emit light can come.
I will talk about working principles of light-emitting diode. So, when the diode is forward biased, the minority electrons are sent from P to N, while the minority holes are sent from N to P. At the junction boundary, the concentration of minority carriers increases, while the excess minority carriers at the junction recombine with the majority charge carriers. The energy is released in the form of photons on recombination. In standard diodes, the energy is released in the form of heat, but in light-emitting diodes, the energy is released in the form of photons. We call this phenomenon electroluminescence. What is phenomenon electroluminescence? Electroluminescence is an optical phenomenon, an electrical phenomenon, where a material emits light in response to an electric current passed through it. As the forward voltage increases, the intensity of the light increases and reach a maximum.
Application of LED. LEDs find application in various fields, including optical communication, alarm and security systems, remote control operation, robotics, and action. Its found usage in many areas because of its long-lasting capability, low power maintenance, swift response times, and fast switching capabilities. I will tell you a few standard LEDs. First, LED used for TV backlighting. Second, LED used in automotives. Lastly, LED used in the dimming of lights.
Laser diode. A laser diode is semiconductor that use a PN junction for producing coherent radiation with the same frequency and phase, which is either in the visible or infrared spectrum. It is also called an injection laser diode, and the technology is similar to that found in LED. Type of laser diode. Double heterostructure laser diode. Heterostructure is a material that is sandwiched between two N-type and P-type materials. Because of the presence of heterostructure materials, this type of laser diode is called a double heterostructure DH laser diode. The main advantage of this diode is that the active region is used for better optical amplification. Quantum well laser diode. The quantum well is a very thin middle layer in the diode. The quantum energy is used for converting electrons from higher energy to lower energy and is responsible for better efficiency. Separate confinement heterostructure laser diode. There are two additional layers along with three layers. These layers have a lower refractivity index and the emission of light is also improved. Vertical cavity surface emitting laser diode. In this type of a laser diode, the optical cavity is along the axis of the current flow. Next, we go through application of laser diode. Firstly, consumer electronics. This includes laser printers, CDs and DVDs player, and fiber optic communication. Secondly, medical application. Laser diodes are used for the elimination of unwanted tissues and tumors and also in dental medication. Thirdly, scientific instrumentation. Instruments like spectrometers, rangefinders, concert lens measurements can be done with the help of laser diode. First, industrial application. When it comes to industrial application, laser diode is preferred as it is a source of a high-intensity laser beam and used for cutting, drilling, welding, and enabling. Fifth, medical application. Laser diodes are used for the elimination of unwanted tissues and tumors and also in dental medication.
So now I will talk about conclusion. So in conclusion, electronic devices have had a profound impact on our life. They have evolved from cumbersome machines to sleek and powerful tools that enhance our communication, work, and leisure. However, we have divided the conclusions into three, which are the conclusion for photodiodes, LED, and laser diode. So for photodiodes, we know that almost any electrical equipment can be modified to use photodiodes, which are optoelectronic devices with a wide range of types and applications. They are compatible with infrared light sources such as laser, LED, neon, and fluorescent light. Additionally, they cost less than many light detector diodes. For LED, we have identified that a light-emitting diode, or we can call it LED, is a semiconductor device that emits light when an electric current flows through it and converts electrical energy to light energy. It is a type of special diode whose PN junction is made from a compound semiconductor, and consists of heavily doped semiconductor with a very thin layer of PN junction. Last but not least, we also know that laser diodes are an integral part of modern technology with a wide range of applications across various industries. Laser diodes are semiconductor devices that produce light by optical amplification and electromagnetic radiation-induced emissions. Thank you.